Our topic is Yagi and dipole. Our speaker discovered the 2-metre band as a schoolboy in Melbourne. Activity was AM on the low end of the band, polarisation was horizontal. FM repeaters were a vague idea for the future. Construction of Yagi antennas was very much the norm then. And for our speaker, lifelong interest in building practical antennas for the VHF and UHF amateur bands. He's not a specialist on antenna engineering, but will draw on the expertise of VK amateurs, many of who are professional engineers. Members, please welcome VK2BCC, Colin Christensen.
Yeah, I'd just like to say, Alan's talk in particular, he's up at the high end there drawing wonderful diagrams and, really talking about the high end of antenna analysis. I propose to be completely the opposite end. I really want to talk absolute basics. But I think the first thing I'd like to talk about is history. We talk about a Yagi antenna, but it's really quite an incredible story in the beginning. We've got here on the left, we've got Dr. Uda, and on the right there, we've got Dr. Yagi. It was actually Dr. Uda that got onto the idea of using a dipole with adjacent elements to achieve some directional characteristics. Dr. Yagi was the senior researcher at Tokyo Imperial University in 1926, it was 1926. Anyway, Dr. Uda worked out that you could achieve this directionality with elements, and of course it all came together. And in 1926, as academics do, a paper went out there in the Japanese world, which didn't really create that much interest. 2 years later, 1928, an English paper came out which did go to the rest of the world. And the rest of the world, did realise that there was something special going on here. And in the 1930s, the Western world really developed using Yagi antennas. So 1928, the world heard all about it, but the Japanese still really didn't know what was going on with this, despite it going out there in the academic world. Moving forward to 1945 wartime, when Japan invaded Singapore, apparently there was a Japanese soldier, we'll say, who was just looking at some papers there, and he saw this English discussion, and apparently not even recognising that Yagi might have been a Japanese name. And, he said to the English people nearby, what's the story here? And he was told, well, it's your Japanese academic world that's discovered all this. So the point being that up to that particular point, the Japanese weren't doing anything with Yagi antennas, but in the 1930s, of course, VHF was becoming very important, and the early development of radar, which of course we all know was really, really important in wartime in Europe, was all focused on using Yagi antennas. Anyway, so the story there is that Japan woke up at that particular point, but the Allies were well and truly ahead. Totally unrelated to antennas, there's a similar story in relation to rockets. Apparently the really early experimenting with rockets went on in America, or we know historically it goes back to China and so on, but the modern development of rocketry was a man called Goddard, who was an American. And he also wrote his work up and went out there in the English language academic world. And as it was with the Yagis, no one really took any notice. Anyway, in wartime, when the Second World War was finished, and of course the Allies wanted to know, how did you build these V2 rockets, etc.? And the Germans said, well, we got it out of this American paper sometime before. So there's a couple of anomalies in history there. Okay, now, very, very basic theory. Alan went quite deep in theory of antennas here before, but I'm just going to do the basics. If you have an antenna like this, it will have a lobe out the front a bit of a lobe out the back, a couple of little ones on the side, but significantly we'll have a series of nulls. And something that's highlighted on there at 19 degrees up and down from the centre will be the half power points. And the beam width of an antenna is defined by measuring the half power points. If you can measure it, and I'll put it to you, that's not straightforward. What Dr. Uda had come across, starting with the basic dipole, and if you put an element near to it, which is slightly long, in other words, a lower frequency, the radiation will be skewed away from the longer element. Similarly, if you make a shorter element, it will draw the radiation forward. So when we have an antenna like this, the radiation, of course, is out along the line of directors. You can have lots of directors if you like. Anyway, that's very elementary theory, and that's what you actually end up with. Oh yeah, just something else that sort of gets left out of discussion. We often quote the gain of the antenna, and there's two ways of doing it. We can relate it to a dipole antenna, and we will call that dBd, or we can consider it to be an isotropic, which is a pinpoint radiation, and you'll see reference to dBi. Okay. Now, polarisation, having a discussion with Alan earlier, there's been all sorts of academic studies as why one uses horizontal or vertical. Vertical, of course, is really good for mobile applications. It's really convenient to have a vertical antenna on a vehicle, of course. But when it comes to broadcasting, there's been various studies as to why horizontal is better. But again, Alan's pointed out a little bit earlier that apparently our trees are basically vertical, and radiation, if you transmit vertically, there will be a significant amount of absorbing, by the bush. So, that's just one factor. There have been very formal studies of why you use horizontal polarisation for broadcasting. And the outcome, of course, is that most of our television is indeed horizontally polarised. And the only times that they use vertical is when they're hard up for channels and they've got to have, they've got to separate another adjacent service. Okay, now, I want to talk about being practical. Next slide, please. If you look closely at this is my first antenna that I built in 1963 as a schoolboy in Melbourne. The elements are fencing wire. You can fix anything with fencing wire. The dipole is indeed some aluminium that I've scratched from somewhere or other. The boom is just a broomstick, I think, and it's attached to the. It's actually a stink pipe on the laundry, I think. Just wrapped up. But if you look really closely, what you'll see, the feed line will be 240-volt twin flicks. Now, that was really hard up as a schoolboy, and that worked fine. I don't know if it was particularly long because I think someone probably took pity on me, and I did eventually set up some coax on it. But with that antenna in Melbourne, 1963, before repeaters, it was a real thrill for me. During the openings the Tropo openings in Melbourne, you hear the VK5s and you hear the VK7s. And a lad of 16 discovering all this, that was a real thrill. And that was with my little fencing wire antenna. And of course, one moves on from these things, but that antenna, it was very clear to me that it had a big lobe at the front. I could point it at the station I'm interested in. I could turn the back, yes, there was a bit of a lobe at the back, and there were nulls on the side. It was a working antenna, made out of fencing wire, broomsticks, and 240-volt flicks, mains lead.
What, no duct tape?
No what?
No duct tape? It wasn't invented there.
Well, no, probably not. Was duct tape really there in 1963? No, here we go. Now, where I'm going here, and you can see an example here, is the fantastic source of antenna bits coming from our television receiving antennas. They're all out there. and a few years ago, when we rearranged the broadcast spectrum and abandoned all the channels below channel 6, 174 megs, a lot of people sort of tossed out their old antenna. They had long elements of channel 2 or channel 3 or channel 0 if you live down near Wagga. And they're all over the place. I've collected dozens of antennas. This is an example. Most of my antennas really originate with bits and pieces, left over from the antenna world. Television antennas in general, I get the impression that the engineering behind it is pretty crude. They're trying to achieve a massive bandwidth. Originally they want to go from 200 megs down to 50 megs, and you can't really do it efficiently. So a television antenna was really quite crude. And you find, when you look at a lot of them, as I've really gone out to do, they do all sorts of strange things. These ones, of course, got a nice little plastic fitting, and that worked out quite well. But they come up with all sorts of obscure mechanical arrangements, for mounting elements. Now, when it comes to making your homebrew antenna such as this one, one of the difficulties that I come across all the time, it's very hard to really get your element at right angles and have them all the same. If you've got a drill press, you can really bore a very nice right angle hole in your boom, but in most people, just a hand drill, and you're probably about right. Anyway, if you go through the handbooks and the stuff on the web, there's dozens of different ideas as to actually how to mount elements on a boom. It is important to try and, if it's going to be on the boom, you really want to have it electrically connected to the boom. But a better arrangement, which we don't really ever see, is to actually mount the element a little bit away from the boom, so the boom really isn't having much influence. Anyway, those are some of the practical things. Picking up that point, none of us have got a fair nickum access to any formal test range. And I really, my experience is you swing it around, you can easily see that it's got a lobe at the front, nulls at the side, a little bit of a lobe at the back. Okay, now what I'm getting at here, we've already touched on today the readily available VNAs, Vector Network Analyzer. They're all out there, wonderful machines, buy a dozen for $2 bob. My experience has always been the good old-fashioned SWR meter, and this is just an example of you do a plot, you put your transmitter on every 100 kilohertz or something like that, measure the SWR, and ideally you've got a dip where you want it. If the dip's off somewhere else, well, ideally you've started with longer elements, so it's a lower frequency, so you can trim them back and get it just right. Okay. VNAs, wonderful machines. I've got one myself, but I haven't really worked out how to use it yet. Isn't it fantastic?
Is that your trailer, Peter?
He wishes it was.
There's 14 elements in that, and it's on the. I just picked that picture off the web, and it's somewhere in China. No real indication as what they were doing, but it really would be interesting to know whether they really got it all to work and so on. Okay, now touching on VNAs and sort of modern, sophisticated ways of looking at these things. Of course, there are many antenna design software on the web. Lots and lots. Have fun. I'm sure you've already gone down that track, but I'd like to highlight one in particular, VK2BCC, 5 Delta Juliet. His program is he's a local, and it nicely relates to us. He focuses on a German fellow, DL6WU, who really, fine-tuned the process of long Yagis. Recommend that you do look up VK5 Delta Juliet. Now, also, while throwing some call signs in, I haven't really got any of their material here, but it's out there. There were two people here in Sydney that were really important when it comes to ham radio antenna design. Guy Fletcher, VK2 Kilo uniform, and Gordon McDonald, VK2 Zulu Alpha Bravo. Both these gentlemen, really went into it. Gordon's last antenna, he left Sydney, he went to live in the western side, but his array at Barara was 4 15-element Yagis, which all sort of stayed in the ham radio world, and I've got 2 of them via Bob over there, with a few elements cut off. And I think the other 2 parts of that are somewhere up in Newcastle. Anyway, those 2 people, if you look them up, they're really important. They really did focus on building good Yagi antennas for us radio amateurs. The Weber's chock-a-block with material. You find anything you like. All the handbooks discuss Yagi antenna design. Now, if anyone's interested, as I say, I've collected a few TV antennas over the years, so I put a few little bundles together, a suitable beam and some elements. If someone interested to get a starting point, I've got a few of them out in the car there. And that's one of my antennas a couple of years ago in a Blue Mountain snowstorm. So,
What effect did that have? What effect did the snowstorm have?
I don't know if I was more interested in just how pretty it was. But standard story in the morning, dead calm, been a snowfall overnight, it just sits on the antenna like that. It was on that occasion, and there were others. You can actually see some wire antennas there, but there was a snowstorm when the snow accumulated on the sloping wire, and that was just beautiful. So, anyway, that's the end of my presentation. Any questions?
You sort of seem to have stuck with one design then that works for you, or you tried, obviously then you could have a whole dipole or just a regular dipole driven element. What matching you use?
No, I've played with various things. I've certainly started looking at the design in the handbooks.
Yeah.
The RSGB, which a book that I got as a young lad, there's a nice little 6 element in there, and I built that several times. But all the other handbooks have antennas and design, but certainly in more recent times I played with the 5DJ program. So I've played with lots of different designs, and that's another reason why I when you get across it, you don't need sophisticated instrumentation. You can tell it's working because there'll be a lobe at the front, there'll be a little lobe at the back, and there'll be nulls off to the side. Now, we can get really scientific and get our VNA out, and we could really get wound up. But if you're a working antenna, unless you do something radically wrong, it's going to be fine.
Like you've got that one there. What's that design like?
Well, I've got no idea what it was built that one on, but it does what you do. It has a nice lobe out the front, can work to VK1s, and that's it.
Okay.